Yeah. Hi, sir. My name is Parveen Kaur, and me and my friend Aditya, we have worked on this blockchain assignment, and we have mentioned the course ID and our email address and student ID here. So the use case which we have picked up for our assignment is insurance company. So what currently is happening, let me explain the problem definition first. So in the insurance company use case, what current scenario is, whenever a person who is buying a policy from insurance company is falling sick, that person needs to get the money for the treatment from the insurance company. So for that, there are two ways in which that person can get that money. So one is like, he can go ahead with the treatment, and once the treatment is done, he can show the bills and everything to the insurance company, and the insurance company can uh, pay that money to the customer. And other way is the uh, customer can the insurance company can directly get the details of the treatment and bill from the hospital, and they can directly settle the amount with the hospital. So in this process, the main problem is it's taking a lot of time in the initialization of the process, and the document verification, and because it has a lot of manual process involved. So what we are trying, so who is impacted by the problem, mainly are like people who have insurance, who are trying to get use their policy for their treatment, because they need to take all the documentation to once to the hospital, and then again to the, I mean, they have to take the documentation from the hospital and then take it all to the insurance company. So it's a lot on their head. And for hospitals also, it's taking a lot of time if the insurance company is delaying, so the bill settling is taking a lot of time, and the insurance company will have to contact both with the customer and the hospital. So it's a big task for them as well. So how they are currently trying to solve the problem is, the hospitals and the insurance company are having direct tie up between them. So some people from insurance company are dedicated for all the verification, for I mean, for making the verification process faster, and they are sending some of the persons from the insurance company to the hospitals to see if everything is in place, and that's how they are trying to resolve the problem, but still it is taking a lot of time. So what the solution we are proposing here is, we are trying to do at least half of the things through the smart contract, whatever we can do. So this will come with the many benefits, like the verification of the documents could be done through the smart contract, and and there is no need for only for the customer to go again to the hospital and again to the insurance company for the settling of the bills. And because in this smart contract, we'll be introducing the concept of multi signature. So once one party is one party is okay with signing the contract, they don't have to go back and forth to the other party. So once they give their consent, other party can give their consent, and the process will be really fast, and it will also encourage the transparency of the process. So frauds and all could be very less because of this process. So if you go down a little, yeah, so I have already talked about the solution here. So what all it is enhancing is, so what are the challenges we will be facing if we implement the blockchain solution? So one thing is, if we are verifying the verifying the illness details through the smart contract, or let's say we are verifying the policy details, like how much premium is left with the customer to be paid. So all and midway, if the person is changing the policy or upgrading the plan, so we'll have to make the changes in smart contract, so which is a very difficult task. And scaling of the services and policies will also take a lot of time and lot of effort. So these are few of the challenges with the insurance through the blockchain technology. So there is a Solidity code for this as well, which Aditya will explain.
Hi, sir. This is Aditya. So I'll be explaining the Solidity code which we wrote down our own for this problem. So let me share the Remix IDE. I'll explain the code here. So this is the Solidity version which we are using right now, version which is greater than 8.7. And this is the one license which we just commented here, just which we are using. And this is our contract insurance. So let me explain what all variables we are using and what is the purpose of them. So this balance is for the will show us the balance of the entire contract, like how much money is present in our contract. So how many ethers are present in our contract, and the owner is the owner of the contract. It will just show the owner of the contract. And get ID for address. I'll explain this below when we add another um, other function which we use there. So I'll explain it there. And then there is the insurance record. There is a structure which shows all the policy data, like how the user, which user has paid how much money, what is the address of that user, how much money he has paid, what is the expiry of his claim. So we'll store all those details in this insurance record structure. And there is a mapping for that insurance record structure so that we can use in if conditions. So there's the mapping for that. And there is a constructor to just get the owner information, like owner address. Now there's a first function in our contract. So what happened was when we are trying to create a new user, we need an ID for that user. So instead of using normal IDs, what we did was we thought to use the address of the person as an ID. So for that, what we are doing is we are converting the user address into the ID. So for that, what we have done is, this is the function. It takes the user address and it provides the ID of that particular address to get ID for address. So this is the variable which I have declared on the top. And then this is the receive function in this insurance contract. This receive function is used to receive money for our contract. Whenever someone provides our contract address and then do a transaction, all that money which is transacted will be dealt with this receive function. So we need to make it as payable. Unless we make it as payable, it won't be able to receive money. And we need to make it as external. Unless we make it as external, other users cannot use this contract for sending money. And now, so the first statement is we are once we receive money, that value money is added to the balance, so that we'll keep track of the balance, like how much amount is present in our contract. And the next point is the ID. So what, as I mentioned above, we are taking the user's address who is sending money, and then we are converting it into it respect to ID. And this is a mapping for the insurance record. So now the first condition here is, so whenever we receive money, we are doing two things. In this function, we have two functions. One is we are creating a user, and the other one is we are updating a user. Suppose if there is a new user who is sending money to our contract, so what we are doing is we are creating a new user for that. We are creating a new policy for that user and then adding all the details. Or if an existing user sends money to our contract, we will update those details. So I'll explain here how that happens. So this one small condition which we applied is we are only accepting 10 ethers at a time for a single transaction. So as I mentioned, 1 ether equals to this much VEI. That's why I just mentioned this VEI. So this is the first function. We are only accepting 10 ethers at a time for a single transaction. Now, once we receive money, what it does is it takes the ID of the user. So now we are taking the address and then converting it to ID. It takes this ID of the user and checks if it is already present in our structure, like in our data. And then if it is not present in our data, then it creates a new user. Like, so this is all for creating a new user. Now it's sending the user's address into customer address variable. It's sending the amount, how much the value is sent, claim address, claim expiry date. Claim expiry date, what we are doing is for every 10 ethers, we are extending the claim expiry by 1 year. Today plus 1 year. So, and then value is set to true, signature count is set to 0, hospital count, if these values are not yet required, so we have set it to 0. Now we are pushing this record to the array. In the second case is, if the user is already present, he is transacting once again. So he has sent 10 ethers once again. So what we are doing is, first we are adding that money to the user account, and then we are adding his policy by 1 year. Like, we are extending his policy by 1 year again. So how many 10 ethers he will send, that many years he will get the claim. So this is for the receive function. And then we had another function to sign the records. So in this process, what we are trying to do is, once suppose if the user has already paid 10 ethers, and then user has a medical issue and he goes to hospital. So hospital, what it does is, hospital takes the address of the user, and then hospital creates a request for us by signing that record, telling that I want 5 ethers, his total bill was 5 ethers. Here they will give us the reason for that, and then they will sign the record. And once they sign the record, the user will check this transaction and he will sign the transaction once again. Once there are two signed by, one is by the hospital and one is by the user, the third signature will be done by the contract owner. So once the third signature is done by the contract owner, money is transferred from the contract to the hospital. So this is the signed record function for that functionality. So this signed record takes ID, amount, in the description illness, like hospital provide what is the illness that person has. And this is a public function which we described, so everyone can see that. And again, I'm creating a mapping for this one, for the structure. Now here we had two conditions. The first condition is, whenever a hospital requests, suppose the customer has 10 ethers in his account and the hospital is requesting for 11 ethers. So since we do not have that much money in the account of that person, so what we'll do, we'll reject that account, reject that transaction at the first place. So there is the first condition. And the second condition is, suppose if no single person can sign that transaction 2 times. So this signature, this will keep track of all the signatures that a particular address has sent. If it is more than 2, it won't allow. I mean, if it is more than 1, it won't allow to sign that transaction once again. So this is for the second condition which we are using. Now, so as I mentioned before, the signature count should, first signature should be done by the hospital. So when the signature count is 0, this is for the starting of the transaction. If there is no, if none of the hospitals has taken claim for this person, though, so the signature count will be 0. So now a hospital is asking to send us 5 ethers. So for that, if the signature count is 0, what we are doing is, we are adding the signature count to 1. We are adding the address who is requesting, and we are adding that signature count of signature to 1, so that he could not sign 2 times. And then we are adding the signature count of that particular record to 1. And now we are taking the hospital address so that we can send money to them back. And then we are taking the amount which hospital has requested and we are saving it in the record. And then we are taking the description of illness and we are saying it in the user record. So this was the first signature. Hospital will sign this first signature. And the second condition is, only the user or the patient can sign. A patient or the owner of the that particular policy, like the user who has the policy in that contract, can sign the second signature. So we are taking a condition that if the signature count is 1, like hospital has already signed, so the signature count will be 1. So when the signature count will be 1, only the customer should be signed. So we had a condition here like required. So only messenger or sender means it will take the address of the person who is transacting the second signature, and it is checking with the customer address which we had in the records. So if that so it makes sure that only the customer is signing the second transaction. Now again we are making sure that the signature count of that particular address is only 1. So we are making it to 1, and we are adding the signature count for that record. Now this is the third signature where the owner will sign. So this is to make sure that owner is telling he has checked all the conditions like illness what he has. So he accepted that he accepted to send money to the hospital. So now the third signature should be only done by the owner. So this condition will make sure that the third signature will be only done by the owner. And then again we are making that this owner has signed only once, and we are incrementing the signature count. Now this condition is to make sure this condition is hospital okay. Oh yeah, address payable. Okay, this condition is to make sure that we are making this hospital address which we had in the record is just a format of address. It's not payable address. So to make it as payable, what we are doing is we are using this function address payable. So this function will make this address as payable address. Only payable address can be used to send money. So we are making it as payable address. In the next record in the next line is where we are sending the actual transaction. So we are telling that this address should be, we need to transfer this much amount, the amount requested by hospital to this address. So this transaction, this line will make the actual transaction. And then again, what we are doing is we are reducing the amount from that particular person's record. So in the same way, we are reducing that amount from the balance. In the same way, we are doing all this to make sure that whenever the next hospital sends a request, it will be created as a new transaction. So this is what we had in this Solidity code. And the main reason why I commented this one is when I include all these lines, the transaction is getting out of gas because there is a lot of if conditions and checking. So I think it's getting out of gas and we are getting a VM error. So I just commented this for now, but this code is working fine. We are only getting that out of gas error. So now I will demonstrate how this works. Let me compile this. So it's working fine. So now let's say this first 5B3 is the owner of the contract. So I am deploying this contract on his name. So I have deployed this contract. So there is our contract, I have deployed it. And now let's say that the second address AB8 is the patient, and the AB 4B2 is the hospital. So now what I'm doing is from the patient accounts, now we don't have any, let me show you. So this is the patient address. We don't have this record in our contract yet. So as I mentioned, this get ID function, it will take the address, get ID. Once we get once we make this transaction, what it will do is it will show the value of get ID. He's here. So for this particular address, we are getting the ID. So now when I check, this is the insurance record which we have. When I place the ID and check the insurance record for this particular ID, there is no value for this ID because there is no user still who has registered in this contract. So what we need to do, we need to transact some amount from this address to our contract. So for that, what I'm doing is I'm sending 10 ethers from this address to our contract. When I click on contract, it will send 10 ethers to our contract. You can check now again, if you check for the same ID, see you're getting that the amount is this much. There is a form of WEI. So this will be accounted to 10 ethers. And we got the address of the customer. Yeah, and signature count is 0. Since we don't have the hospital address, it is set to 0. So, and the claim expiry date is this one. So this claim expiry date is saved in the format of minutes. So what we need to do, if we want to get exact time, we need to divide it by 24 and 24 and by, sorry, divided by 60, 60 and 24. So we'll get the exact date. So for now, we are leaving this like this. So if we check the balance of this one, so we are having an amount of 10 ethers. And if you want to check the balance of the contract, now we are having an amount of 10 ethers. And this is just to show the owner's address. We can make it private if you want. We just to demonstrate, we have shown this one. Now, so now this account, now this person has 10 ethers in his account, and the claim expiry date is this one. So what I will do, so if you can check this claim expiry date 10, let me save this and show you how this works. So this is the claim expiry date before. Now I'm sending 10 ethers again for the same address. So what it does is it will increase the claim expiry date. When I check this transaction once again, as you can see, this claim expiry date has been increased to 1 year once again. So how many, if 10 ethers you will send, that much, that many years you will get the claim. This is just just for demonstration. We had a simple policy here. We can add more complex policies if we want.
Yeah,
So
the
now,
amount is also 20 ethers now.
yeah, the amount is also 20 ethers now, if we can see, and the balance of our contract will be also 20 ethers. So now let's say the third one is the hospital. So this person has admitted in the hospital, and this hospital, what it is saying is, let's say I'm doing a transaction with you. So the hospital also can get the ID of this patient and check how much amount he has, and how much amount that patient had. He can to just check if he can pay that amount or not. Or the so using this particular, so what we do is using this particular ID. So this function is to sign the record. So what we will do, we'll give the patient ID, we'll give the amount. So amount right now I'm giving it in WIE. So let's say the hospital is asking for 10 ethers. So this is amounted to 10 ethers, and the illness description we can provide something like I'm just providing fever, and I'm doing a transaction now. So now if you see, if you again go to this insurance record and check, now the signature count is 1, and the amount requested by hospital is 10 ethers, and the hospital address is 04B20, which is the address which actually has, which is a hospital address 04B2, which has signed that particular transaction. So now the first signature has been completed, and now the second. Okay, let me demonstrate a scenario where if this particular hospital can sign 2 times. So what I will do, I'll just do the same transaction once again, and that transaction will get failed. If you can see, this transaction has got failed because only one, we had a condition where only one person can sign once, as per this condition. So as per this condition, this transaction got rejected. So the second signature should be the patient signature. The patient is this one. So this, from this address, what I'm doing is I'm signing this contract once again. So the patient will check all his details, like how much amount hospital has requested. So what is the hospital address, is correct or not? Is illness reason, is it correct or not? And then what he does is he signs this record saying that I'm authorizing this transaction also. So when he clicks on transact, so now if you can check the count once again, the signature count went to 2. And now even the user also cannot sign 2 times. I can demonstrate that too. If I sign again, it will throw out an error same. Now the third signature should be done by the owner of the contract, which is the first one. So now let's say this is the let me, okay, it's not, I'm not able to take a screenshot now. So let's say there's the amount in the 79. So okay, there's the hospital address. So hospital has 99 ethers right now, and so what I will do is okay, and our contract has 20 ethers right now. So once the owner signs this contract, 10 ethers will be transferred from our contract to the hospital. So right now it's 99. It should be 109 after the completion of signature. So as a owner, I'm transacting this one. Transaction got completed. balance. Okay, let me show you. Okay, the balance of this particular person has changed from 20 to 10 ethers. And as you can see, the hospital balance has raised to 10 ethers, that is 109. So the transaction has been completed. So this is both the demonstration which we tried to provide. And since this balance and everything did not change because of this, we had commented this one because the gas is getting out. So if we include all this, this records also will get updated. So now by this process, what's happening is the transaction is being the claim process is being made very easy. Like they just need to sign that record. Hospital provide those patient details. Patient need to check those and sign that, and then contractor this contract owner or policy owner need to check and sign those details. So there is a user can check, user or hospital or anyone can check where the transaction is being delayed, or there is a full transparency like how much amount he has claimed. So every can see those details, every can see where the process is where the particular claim is being stopped or where the particular claim process is right now. So this is what we tried, so we thought to demonstrate here.
Yeah, and one more thing, just to point out, for now we are keeping the condition as how much amount user is sending in the contract account, that much only he can spend. It's like in a real time scenario, we can set a premium amount which once the policy started, up to that premium amount that customer can use. But for now we are keeping it as much as the customer is sending into the contract amount account, that much only he can spend for now.
Yes, we can add number of policies here, and just for demonstration purpose, we had provided a simple policy just so it will be easy to understand.
Yeah, thank you.
Yeah, thank you.